Imagine this: the air around you suddenly becomes nothing. No resistance, no warmth, no life-giving essence. Your lungs fill with emptiness. Your blood cries out for the invisible force that sustains every heartbeat, every thought, every second of life. For just 10 seconds, oxygen vanishes from our planet. 10 seconds. It seems impossible, unimaginable, yet what would happen? Today, we step into a world stripped of its most vital element. The answer is both terrifying and astonishing. Oxygen, a colorless, odorless gas, the silent hero of life on Earth. It makes up nearly 21% of our atmosphere, fuels every cell in our bodies, and powers the fires of life itself. Without it, combustion stops. Our cells suffocate. The planet itself begins to unravel. But what if, just for 10 seconds, every molecule of oxygen simply disappeared? The question may sound like science fiction, but the consequences would be immediate, violent, and profound. To understand the impact, we must first grasp what oxygen truly does. In humans, oxygen binds to hemoglobin in red blood cells, fueling metabolism and sustaining life. It powers the brain, heart, muscles, every organ. Beyond our bodies, oxygen enables fire, drives the chemical reactions that allow ecosystems to thrive, and even forms a protective layer in the upper atmosphere, shielding us from deadly solar radiation. It is, quite literally, the breath of life. Remove it, even for a heartbeat, and the consequences ripple outward like shockwaves through reality itself. Earth has not always had oxygen in its atmosphere. Roughly 2.5 billion years ago, during the Great Oxidation Event, oxygen first accumulated in the air, transforming a planet once dominated by microbes into the cradle of complex life. Since then, oxygen has remained remarkably stable. Our lungs, our hearts, the very fires that warm our homes, all adapted to its presence. Its sudden absence, even for 10 seconds, would violate the laws of evolution, chemistry, and physics simultaneously. Now, let us walk through what would happen, second by second. The moment oxygen vanishes, the air becomes an invisible vacuum for breathing. Human lungs, accustomed to the gentle pressure of gas, collapse inward slightly. We begin to suffocate, though the full effects of cellular hypoxia have not yet kicked in. Every fire on Earth flickers: candles, stoves, engines. Combustion ceases instantly. Gasoline in cars stops burning. Jet engines sputter. Water molecules remain, but with no oxygen to support cellular respiration, humans and animals experience the first panic responses. Heart rates spike as adrenaline surges. Lungs gulp at nothingness. The atmosphere's chemical balance shifts violently. Nitrogen, which makes up 78% of air, remains inert, but the absence of oxygen allows minor chemical reactions to accelerate in dangerous ways. Metals exposed to air, like iron, momentarily halt oxidation, and sparks from machinery could ignite elsewhere once oxygen returns. The vacuum effect begins to impact small spaces. Pressurized environments, airplanes, submarines, laboratories, experience a subtle, almost imperceptible drop in pressure. Objects expand slightly. Oxygen-dependent processes in the human body accelerate in reverse. Brain cells begin signaling distress, leading to a sudden, sharp headache in some individuals. The retina, dependent on oxygen-rich blood, starts a temporary visual distortion. Larger fires continue to sputter, and industrial machinery dependent on combustion fails. Power grids reliant on gas turbines experience sudden drops. Across the globe, sensors detect a mysterious environmental anomaly. Birds, mammals, insects all suddenly experience a near-total lack of oxygen for a heartbeat of existence. Some creatures, like humans, can hold their breath. Others, like fish in oxygenated water, are unaffected for the moment. Structures reliant on burning processes, like engines or chemical plants, approach a critical tipping point. Internal reactions are halted mid-cycle, creating temporary instability in industrial systems. The 10-second mark approaches. The world is silent where fires once roared. Engines idle. Humans gasp instinctively, their lungs once again filling with oxygen as it returns. Every system recalibrates. There is no lasting death from 10 seconds alone, But the warning echoes through every living and mechanical system. Life is fragile. Globally, the effects are subtle yet undeniable. Electrical grids stabilize, engines restart, and panic dissipates, but only because the disappearance lasted a mere 10 seconds. Had the absence extended to a full minute, many fires would never reignite. Humans without supplemental oxygen would begin dying. Aircraft at high altitudes would fail catastrophically. Even water bodies would start to release dissolved gases, causing temporary turbulence in marine ecosystems. The world would be reminded of how tenuous our survival really is. 10 seconds of lost oxygen is a cosmic warning. Everything we take for granted, breathing, fire, energy, life, is balanced on a knife's edge. Oxygen is not merely a gas. It is a thread woven into every heartbeat, every flame, every thought. Its absence, even momentarily, exposes the invisible scaffolding that sustains life on Earth. We often assume that nature will always provide, that the air around us is infinite and invincible. But a fleeting 10 seconds of nothingness is a stark reminder. We live in a delicate balance, and even the smallest disruption can ripple across the planet in ways we are only beginning to comprehend. So, next time you inhale, remember, this invisible gas, so easily overlooked, is the quiet force that makes life possible. What if we tested the limits of other elements, like water, gravity, or even time itself? The answers may terrify you. They may astonish you, and they are coming in our next journey into the unimaginable.